replace the two wrenches and the force acting on the pipe assembly by an equivalent force and couple moment at point O. Okay, so in this question we have a pipe assembly and two wrenches and a force is acting on the pipe assembly. So the question is asking us to find an equivalent force and couple moment at point O. So this is point O. It is essentially the origin of this X, Y, and Z system. And so we have two wrenches. So wrench 1, let's say wrench 1 here. That's one wrench. And we have another wrench here. Wrench. And we have a force here. Independent force. So if you remember, wrench is an effect where you have a force and a moment vector acting on the same line of action. So it's like pushing and pulling, but at the same time you're rotating around that axis. Pushing and pulling along the axis, and simultaneously you're rotating. So that's that kind of action. So that's the wrench. So within the wrenches we have forces. We have a 300 Newton force here. We have a 200 Newton force here, and moments of 100 Newton meter here and 180 Newton meter here. And we have an independent force here, 100 Newton. Okay. So basically we can call this 300 Newton. Let's call this 300 Newton F1, and this 200 Newton F2, and this 100 Newton F3. Okay, and we can go ahead and call 100 Newton meter as M1, and then 180 Newton meter as M2. Okay, so let's go ahead and write some Cartesian vectors. So force and moment vectors as Cartesian. So once we can write Cartesian vectors, force vectors and moment vectors as Cartesian vectors, then we are good to go. Okay, so let's go ahead and write these F1, F2, and F3 and M1 and M2 as Cartesian. So starting from F1, so we have F1 here as magnitude 300 Newton, and the direction is the Z direction, so that is 300K. Okay, so that's my unit vector along the Z axis. So that's my F1 and my F2. So these are vectors, F2 vector. And okay, so we need to find the components of the F2 vector because it's with an angle with the XY plane, a 45-degree angle with the XY plane. So cosine and sine of that angle would be, so the magnitude is 200 Newton, and we have in the X direction cosine 45 and I, and in the Y direction and in the Z direction we have minus, because it's the, so this is the X component and this is the Z component. It's towards minus Z direction. Okay, so minus okay, this is in parenthesis, sine 45 degree K, and that will be, so that's Newton, and that's Newton as well. Okay, so F2 will be 141.42 I minus 100, okay, it's the same, 141.42 K. Good. Okay, for F3 vector, which is this one, it's simply 100 dot. On the other hand, for the moment, so moment 1 vector, moment 1 is this one, so it's 100 Newton meter K, 100 K. Okay, and for moment 2, I'll be having, as for F2, I'll be having 180 and cosine 45 I and sine 45 k. Okay, and right, that's Newton meter, and that's Newton, that's Newton. Okay, so I have now written my external effects on the pipe assembly system, pipe assembly, as Cartesian vectors. So I go ahead with the solution. So equivalent force and couple moment, equivalent force and couple moment at point O. At point O. Okay. Right. So so I need to find two resultants. So one resultant, so one I need to find FR, so resultant force vector, and then two I need to find MRO, MRO. Okay. So for this, it's simply the addition of the force vectors, and my FR vector is simply equal to F1 vector plus F2 vector plus F3 vector. Right. Okay, and for my MR0, so it's simply the addition of the available moment vectors, so that would be the moments caused by F1 and F2 and F3 if there is one about point O. So for F1 I'll be having R1 times F1 plus, and for F2 R2 times F2. Of course, this is cross product. And for F1, for F3, I don't have any moment caused by F3 because of the line of action of F3 lies on the line where I have my point O. So there is no moment caused by F3 about point O. So that's that, and plus other couple moments which are free vectors, I simply add them, M1 and M2. Okay, so for the force, for the FR, so FR vector will be equal to my F1 is 141.42 I, and I have another, so 100 J plus 300, so that's my F1. For F2 I have 300 minus 141.42 K. Okay, so that's F1, F2 and F3. Okay, so my FR vector will be 141 I plus 100 J and plus 159 K, and the unit is Newton. So that's my FR. Okay, for my MR0 vector, I'll be having, for the R1 times F1, is R1 times F1, so let's go ahead and write R1 times F1. The position vector that I'll be using for R1 times F1 is, this is my F1 vector here. Okay, so that's 300 Newton, and this vector would be my R1 vector. So R1 times F1. So R1 here, R1 would be 0.5 J, okay, and for the R2, so I'm having this F2 here, and R2 would be this one, so R2, and that would be equal to the magnitude of this position vector is 1.1, and the direction is J again. Okay, so let's go down and write the R1 dot product. Okay, so we can actually write this where we left. Okay, so where we left is here. So that would be the determinant of ijk, and for the R1 is 0, 0.5, and 0, and for F1 I have 0, 0, and 300. So that's R1 times F1. And for my R2 times F2, it's going to be ijk, and I'll be having for R2 0, and for the J component 1.1 meter and 0, and for the F2 I'll be having 141.42 and 0 and 1, that's minus 141.42, and that's R1 times F1, that's R2 times cross product F2, and I have the couple moments which are M1 and M2, so 100K is M1, and the other 127.28I minus 127.28K. Okay, so that's basically that. Okay, so that's 127.28 I minus 127.28 K. That was M2. So this is the M1 vector, and that's the M2 vector. Right, so the solution of this whole addition is 122I and minus 183K. That's Newton meter. Okay, so finally, if I just copy and paste, let me just copy and paste this figure here and try to show with a different color pen, like red. So my moment vector is 100, like resultant moment vector is 122I and minus 183K. So this vector lies on the XZ plane. So that would be 120 and 182 somewhere here. So somewhere, let's say here, and that would be the MR 0 vector. Okay, and okay, and for the force vector, I'm having let's draw that force vector with a different color. Let's say green, and it lies on the I component, J component, K component, and we have like I component, J component, Z component, maybe like that, something like that. Okay, so that's my FR0 vector. Okay, so this blue vector and red vector are my equivalent force and couple moment at point O. Okay, so this concludes the solution of this problem. Thanks for listening.